Are you ready? Are you ready for the absolute bestest chapter in the entire world? My favorite, organic chemistry. All right, so in the beginning of the year, we talked all about organic and how organic chemistry is the study of carbon-containing compounds. All right, well, what you don't realize is that it really includes so many things in our everyday life, like the medicines we take, like aspirin. Everything is a carbon-based compound. The plastics and plastic bags, the polyethylene, in our foods, everything we eat, the citric acid, and in our body and how things function, like amino acids. The most important thing for you to remember is what carbon can do. How many valence electrons does carbon have? That's right, it has four. So its structure, its Lewis dot structure, looks exactly like this. It can make four bonds. And if you can remember that carbon can make four bonds, this will also be your favorite chapter. Okay? So carbon can do all of these beautiful things and make these huge linking structures because it has a very specific branch orientation. It has that tetrahedral shape. And that tetrahedral orientation with that bond angle of 109.5 degrees makes it so that it can have your carbon in the center, and then it has a nice branching capability, okay, where you see things coming towards you and away from you, whatever is being bonded to it. But one of the things that we need to realize is that carbon can bond in a multitude of different ways, and we have something called isomers. Isomers kind of sounds like isotopes. Okay, isomers mean that we have the same formula but different structures. Okay, so one of the things that we have seen before is butane, which is going to be C4H10. You can make it in this branched version like so, where you have one, two, three, four carbons all branched together, and it kind of looks like a caterpillar. Or you can have an isobutane, where you have one, two, three carbons, and instead of putting the last carbon on the end, one of these hydrogens right here is replaced with the fourth carbon. So it's kind of like a T-shaped, if you look at that. So here is your carbon links that way versus your carbon links this way. All right, but you'll notice each one of them has your 10 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's C4H10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is also C4H10. So both are correct. So this isomerism can kind of get things to be a little bit of a pickle, but it really kind of allows for you to exercise your brain in lots of different ways. All right, so there are structural isomers, like we saw right now with butane, and there's also geometric isomers, which means that you can have different things on different sides of a double bond. You can have a cis orientation or a trans orientation. And cis and trans have lots of meanings. In chemistry, cis means same, which is usually the same in our general vernacular, and trans means opposite. Okay, so if somebody is transitioning, they're going from one side to the other. Okay, so with our carbon to carbon double bonds, all right, it actually will look more like this. So you will either have something on this side of the double bond, and these guys are just hydrogen, or you'll have something like this, where you'll have your substances here and your hydrogens here. And I know the blue is a little hard to see on the blue. Okay, so here you'll see your special things are on the same side, and your special things here are on the opposite side, while the hydrogens are going to be on opposite sides either. So where have we heard trans before in food? we have heard them with cis and trans fatty acids. Okay, oh, trans. Are trans fats good or bad? Most of you are going to say they're bad. Okay, the trans fats are going to be where you have your double bonds in your compounds in your fat, and you'll see that the big long chains are on opposite side. So this is a very long molecule. Whereas your cis stuff, your oleic acid, your olive oil essentially, okay, all of your plant-based stuff, is going to have everything on the same side. And this is going to be a bent or folded molecule. So which one's going to get stuck in your arteries? That's right. Okay, a lot of these very high saturated animal fats have these long trans fats over here, and it makes it so that it is not going to fit in your bodies well. Okay, whereas the cis fat is actually going to be much better for you. So all of your plant-based oils, your olive oil and your avocado oil, your coconut oils, all of those will be much better for you. There are saturated fats, which means that there aren't any double bonds. Those are better for you than trans fat, but they're not the best. But this is going to be like your bacon grease and stuff like that. And that's a little bit of a way that, cis and trans isomerism comes into play with our everyday lives. Okay, so the next couple of videos are going to be about how we can figure out what all of our orientations are. Okay, so stay tuned for the playlist.